All right, so today we're going to kind of wrap up everything we've been doing with dividing decimals and summarize it all in this one nice note page. So just like with multiplication, we started dividing decimals with models. So for example, if I'm doing 3 and 75/100ths divided into 3 equal groups, I can start that by making our model with 3 7/10ths and 5/100ths. And then I'm just going to start putting that into our 3 groups equally. So I'm going to start just by kind of making a placeholder for our 3 groups. And so as I use them, I'm just going to kind of cross them off. So first of all, each group can get one of our red pieces, which is one whole. And then 7 divided into 3 equal groups. Well, 7 doesn't divide into 3 equally, but I could use 6 of the pieces. So each group is going to get 2 of our greens. And then that last green, when I take that away, it's going to be split into 10 more of our yellow pieces. And now I have a total of 15/100ths, which are our yellow pieces, which I can split into my 3 equal groups. So 15 divided by 3 gives each group 5. And this is probably a little bit easier with the actual number pieces app like we did. But now we can see we've used all of our pieces, and each group ends up with 1 and 25/100ths. So that was when we split it into equal groups, and then now we're splitting it into groups of equal size. So I'm going to look at the same type of idea. I'm going to take 1 and then 25/100ths. And now I'm going to put them into groups that are the size of 25/100ths. So the first group I can make of 25/100ths is actually just our group that's right here. So that would be our first group. And then I have to take my 1 and split it up. So I could split it up into 10/10ths. But when I do that, because I need 25/100ths, I'm eventually going to have to break up some of our pieces. So what I'm going to start to do is then make groups of 2 where I can, and then end up having to split up some of them. So here we can start by making this group, and then I'm going to take this piece and breaking it up into 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So this basically got split into 2 groups. Once again, a little bit probably easier with the number pieces app. And then I can do the same thing here. So I'm going to take this group of 2, and I'm going to take this group of 2, and I'm going to take this 10th, and once again split it into a group of 5 and 5. So all together, we had one group here that we started with, and then I was able to make 1, 2, 3, 4 more additional groups for a total of 5 groups that were made. So models work really nicely, especially when you have the actual blocks or you're using an app where you have the physical pieces, just because it's easier to kind of break those apart. Then we moved on with our exploration, and we started to look at how decimals and fractions are related and how we can use that to start to make sense of dividing decimals. So for example, I can do lots of things to 1/2. I could multiply each one by 3. I can multiply each part by 4. So in this case, this would be 3/6. And when I change 1/2 into a decimal by dividing 1 divided by 2, I end up with 5/10 or 0.5. And the same thing with 3 divided by 6, we end up with 5/10 or 0.5. So even here when we have 56 over 7, I could take each of these and multiply them by 2, and I would have 112 over 14. And either way, when I do these division problems, I still end up with an answer of 8. And the reason that this is helpful is that it gives us the capability of manipulating our decimals to make them easier to divide, kind of like what we were doing with multiplication. So we can end up using powers of 10 to create a whole number for our divisor. And that's the number that we're dividing by. All right, so if you remember, the first number is our dividend. The second number is our divisor. And then our answer is also called our quotient. So if I go back and I think about 3 and 75/100ths divided into groups of 2/10ths, what I can do here is I'm going to start by looking at my divisor. So right now it's a decimal. I want to think of it in terms of a whole number. So what do I have to multiply by 2/10ths to move our decimal point? In this case, I'm going to multiply it by 10. And if I do that to my divisor to keep it an equivalent fraction, I have to also do that to the dividend. So I'm going to multiply that by 10. And now we're looking at an equivalent problem of 37 and 5/10ths divided by 2. And I can do this just using long division. So I'm going to take 37 and 5/10ths. 2 is going to go on the outside. I'm going to bring that decimal point straight up and line it up. And then I can do 2 goes into 3, if we're thinking about it that way, 1 time. Let's subtract this down. I have 1, then I'm going to drop down my 7. 2 can go into 17 8 times, not 6. And that's 16. And even though there's that decimal point, at this point I'm just going to kind of ignore it. I'm going to bring down this 5. So 2 can make, from 15 with 2, we can make 7 equal groups, and that's 14. Now, because I still have a remainder, I'm not going to put that R1 over here. What I can do, if you remember at the end of a decimal, is I can add a 0, and it doesn't change the value. And then I'm going to bring the 0 down to the bottom, and now 2 can go into 10 5 times. So we end up with an answer of 18 and 75/100ths. So things to remember: we can use a power of 10 to change the divisor to a whole number. We multiply the dividend by the same number to keep the problem equivalent. And the decimal point moves up for the quotient. Unlike with multiplication where we had to move the decimal point back, because we're dealing with equivalent fractions, as long as we do the both to the dividend and the divisor, we don't have to worry about moving our decimal point back, because as we saw through our exploration, we can multiply or divide the dividend and divisor by the same number and still end up with the exact same quotient because it's an equivalent fraction, so it has the same value. Let me know if you have any questions. Otherwise, this should go in your binder when you are all done.